The British thermal unit is a traditional unit of work equal to about 1055 joules. It is the amount of work needed to raise the temperature of 1 pound of water by 1 degree Fahrenheit. In science, the joule, the SI unit of energy, has largely replaced the BTU. The BTU-H is most often used as a measure of power in the power, steam generation, heating, and air conditioning industries. It is still used in some metric English-speaking countries. In North America, the heat value of fuels is expressed in BTUs. The notation kBTU or kBTU is often used for 1000 BTU, in sizing of heating systems, and in the energy use index expressed as 1000 BTU annual energy use per square foot of building. MBTU represents 1 million BTU, although the atypical notation MMBTU or MMBTU is sometimes used to represent 1 million BTU. Definitions. A BTU is the amount of heat required to raise the temperature of 1 avoirdupois pound of liquid water by 1 degree Fahrenheit at a constant pressure of 1 atmosphere. As with the calorie, several definitions of the BTU exist, because the temperature response of water to heat energy is nonlinear. This means that the change in temperature of a water mass caused by adding a certain amount of heat to it will be a function of the water's initial temperature. Definitions of the BTU based on different water temperatures can therefore vary by up to 0.5%. OBTU can be approximated as the heat produced by burning a single wooden kitchen match, or as the amount of energy it takes to lift a 1 pound, weight 778 feet. The unit MBTU or MBTU was defined as 1000 BTU, presumably from the Roman numeral system where M or M stands for 1000. This notation is easily confused with the SI mega prefix, which denotes multiplication by a factor of 1 million, or with the SI milli prefix, which denotes division by a factor of 1000. To avoid confusion, some companies and engineers use the notation MMBTU or MMBTU to represent 1 million BTU, and in many contexts this form of notation is deprecated and discouraged in favor of the more modern SI prefixes. Alternatively, the term therm may be used to represent 100,000 BTU, and quad for 1015 BTU. Some companies also use BTU-E6 in order to reduce confusion between 103 BTU and 106 BTU. Conversions. 1 BTU is approximately 1.054 to 1.060 kilojoules, 0.293071 watt-hours, 252 to 253 cal, 0.25 kilocalories, 25,031 to 25,160 feet PDL, 778 to 782 feet lbf, 5.40395 feet 3. For natural gas, in natural gas, by convention 1 MMBTU equals 1.054615 gigajoules. The energy content of a volume of natural gas varies with the composition of the natural gas, which means there is no universal conversion factor for the number of BTU to volume. 1 standard cubic foot of average natural gas yields 1030 BTU. As a coarse approximation, 1000 feet 3 of natural gas yields 1 MMBTU 1 gigajoule. 1 foot 3 of natural gas yields 1000 BTU. For natural gas price conversion, 1000 cubic meters 36.906 MMBTU and 1 MMBTU 27.096 cubic meters. As a unit of power, when used as a unit of power for heating and cooling systems, BTU per hour is the correct unit, though this is often abbreviated to just BTU. 1 watt is approximately 3.41214 BTU. H. 1000 BTU. H is approximately 293.071 W. 1 horsepower is approximately 2544 BTU. H. Associated units. 1 ton of cooling, a common unit in North American refrigeration and air conditioning applications, is 12,000 BTU. H. It is the amount of power needed to freeze 1 short ton of water into ice in 24 hours. 1 therm is defined in the United States and European Union as 100,000 BTU, but the US uses the BTU 59 degrees Fahrenheit while the EU uses the BTU-IT. The therm is used to price natural gas. 1 quad is 1015 BTU, which is about 1 exajoule. Quads are used in the United States for representing the annual energy consumption of large economies. For example, the U.S. economy used 99.75 quads in 2005. 1 quad year is about 33.43 gigawatts. The BTU should not be confused with the Board of Trade unit, which is a much larger quantity of energy. The BTU is often used to express the conversion efficiency of heat into electrical energy in power plants. Figures are quoted in terms of the quantity of heat in BTU required to generate 1 kilowatt-hour of electrical energy. A typical coal-fired power plant works at 10,500 BTU kWh, an efficiency of 32 to 33%.